one more word problem example today. This time I want you to write down the formula T equals 19m plus 65. Again, that's T equals 19m plus 65. And I want you to write down that the T stands for temperature and the M stands for minutes. So what we're talking about here is we're talking about preheating an oven. So a recipe is calling for a temperature of 350 degrees. So, and obviously your oven can't automatically jump to the 350 degree mark. So we're turning on the oven and we're waiting for it to preheat until it reaches 350 degrees. So first things first, we need to decide which one of those variables is our independent variable and which one is our dependent variable. And I've given you a couple of tricks to do that. One trick was if you have a variable isolated, usually that's your dependent variable. So usually this one is going to be our dependent variable. Another trick I gave you was if one of your variables is dealing with time in any way, that's usually your independent variable. And we have one that's talking about time. Minutes is time, and so this is usually your independent variable. And then just using logic, which one depends on the other? The temperature of our oven is dependent on how many minutes have gone by since we've turned it on. So that solidifies things for us. So temperature is our dependent. See if I can hold this board still. Dependent variable. And the minutes is going to be our independent variable. Because temperature is dependent on how long the oven has been preheating. All right, so once we've got that figured out, now we know that this is our input and this is our output. And this time, I'm not giving you the input, I'm not giving you the domain. We're gonna figure them both out. So our goal is to reach 350 degrees. We know degrees is your range. So our range is the temperature, or your outputs, or your y's, or your dependent variable, and our domain is minutes. Those are our inputs. So when you don't know what to start with when we're talking about domain, start with 0. There's no such thing as a negative minute, but we can start at 0. That just means right before you turn on the oven. So at 0 minutes, we plug in 0. 19 times 0 is 0, plus 65 is 65. So what that means is before you turn on the oven at 0 minutes, the oven's already at 65 degrees. That's probably the temperature of your house currently. So then let's move up to 1 minute. After 1 minute, what's the temperature of the oven? So if I plug in a 1, 19 times 1 is 19, plus 65 is 84. So that means after 1 minute, our oven is at 84 degrees. Let's move up to 2 minutes. 19 times 2 is 38, plus 65 is 103. So we're still not up to 350 degrees. Let's try another one. 3 minutes. So we've got 19 times 3. See, that would be 57 plus 65. We're at 122. So after 3 minutes, our temperature is at 122 degrees. And you can keep going and keep going. We're not going to stop though until our range reaches 350 degrees because that's our goal. But I'm impatient. I don't want to keep going until we get to 350 degrees. There is a shortcut here, and so I'm going to show you what that is. How do we figure out how many minutes, that's your M, it takes to be at 350 degrees? That's your T. We've already done word problems like this in chapter 1. This is your temperature, 350, so let's plug in 350 for T to figure out how many minutes it takes to get to 350 degrees. So I'm going to set up that equation real fast. 350 equals 19m plus 65. And so I don't make a mistake on video, I'm going to use a calculator. So we're going to subtract 65 from both sides to get to 85 equals 19m. Then we're going to divide both sides by 19, and I think that's 15. Yeah. So it takes 15 minutes to reach 350 degrees. So if I would have kept going and just plugging in one number at a time, we only got up to like 3 or 4. We'd have to get all the way up to 15 before we reached 350 degrees. So now we're ready for our domain and range, and here's where it gets a little tricky. Not really, but kind of. Our domain is, we're not just going to list the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We're not just going to list them. Why? Because at like 2 minutes, the temperature of the oven doesn't just go from 84 degrees to 103 degrees, like instantly. It's a gradual process. There's also 2 minutes and 15 seconds. The temperature raises in that amount of time. It's not just that at every minute, the temperature of the oven automatically jumps up to the next level. It's gradual. So because it's gradual, we're going to write these as and inequalities. I'm going to write down that it took 15 minutes, so I'll remember that. So the reason we didn't do and inequalities on some of the other examples, let's talk about the juice example. You aren't going to take 1.5 gulps of juice. So it was very clear that you're either taking no gulps of juice, 1 gulp, 2 gulps, 3 gulps, or so on and so forth. But you're not, like, they made it clear that you weren't just sipping it or taking little half gulps. Every time you took in some juice, it counted as a gulp. There's one, took some juice out of the glass. There's another gulp, took a chunk of juice out of the glass. Cannot talk. But now we're talking about a gradual increase. So our domain is talking about the x's, and we're going to write it as an and compound inequality. Our range is about the y's, so we're going to write that as a compound inequality with the y in the middle. So make sure with domain you always use the x, with range we always use the y. And we practiced these with graphs previously, but now we're doing it with a story problem. So domain was talking about minutes. What was the least amount of minutes we could have? We could have 0 minutes. So we're starting with 0, and it could be equal to 0. The most amount of minutes, it went up to 15. At 15 minutes, the oven is completely preheated. So then we stop. So our x, our smallest amount was 0, because you can't have negative minutes. Our biggest amount was 15, because that's when our oven became fully preheated. Now let's talk about the y's. Our smallest y. Y's are talking about the temperature. Actually, I probably shouldn't use x and y. Back up a step. Let me use the variables. So this was m for minutes. This was t for temperature. That might help us out too. So our temperature, what was the smallest temperature it was ever? Started at 65 degrees. Remember when we plugged in a 0, we got 65? So it started at 65, and it was equal to 65, so I'll put an equal to sign there. And then the highest temperature we wanted, the stopping point, was 350, and that's what happened at 15 minutes. And again, an equal to sign. So 0 minutes, 65 degrees. And then the maximum amount was 15 minutes at 350 degrees. So I just wanted to show you at least one example where your domain and range are continuous, and so we write them as and inequalities. Normally, if it's not continuous, so the opposite of continuous is discrete, it'll tell you what the domain is, and it'll list those numbers. It'll say the domain is 1, 2, 3, 4, and 5. What's the range? When it doesn't do that, a lot of times you can figure it out on your own, and it's going to be continuous. But to determine which one, just kind of ask yourself, is there such thing as 1.5 minutes? Whereas with the juice, we couldn't have 1.5 gulps in that instant. Or like when we were printing papers, your printer isn't just going to print half of a page. If it's printing, it's going to print everything that's on that page. So kind of a fine line. Don't worry about the details so much. I just want to make sure that you know how to find the range if the domain is already given to you, and then how to find your starting and stopping points if you have to find them both. All right, let me know if you have any questions on this.